Hello everyone. Here we're going to see some of the numericals on IC engines. Right, before going to that, we need to see what are the formulas to be used to solve the numericals on IC engine. Right, that first one is the indicated mean effective pressure. Right, the definition of indicated mean effective pressure, it is the mean or average pressure. It is the mean or average pressure acting on the piston during power stroke. That means during power stroke, what will be the average pressure inside the engine cylinder which is acting on the piston? We call that power as an indicated mean effective pressure. That pressure is called as an indicated mean effective pressure. This is obtained by indicator diagram. Right, indicator diagram, that is the indicator diagram on the PV diagram for one cycle at that load is drawn with the help of indicator fitted on the engine. Right, this is done with the help of a instrument called planimeter. Right, with the help of that instrument we're going to draw the indicator diagram. Right, what how the pressure, how the piston is moving with respect to that, and how the pressures are acting inside that one. This pressure with respect to the pressure and volume, we're going to draw the indicator diagram. Right, in pressure in y-axis and volume in x-axis, we're going to draw the indicator diagram. Right, if we have the PV diagram like this, like we'll be having the PV diagram like this. Right. If we get this PV diagram, the area of the indicator diagram is this one. This will be the area of indicator diagram. This will be the length of indicator diagram. This is capital small letter A, and this is length L. Right. This will be the length of indicator diagram and area of indicator diagram. That is pressure and volume here. Right. Now, what is the mean effective pressure? Mean effective pressure, it is represented by letter PM, P suffix M. That means the net area of the indicator diagram. That is this area here, A, and then the spring value of the spring used in the indicator. That is in terms of bar per meter. That means the spring value of the spring used. That is the spring value here. We are taking the planimeter spring there, that is the spring value of the spring used, that is S here, and then length of the indicator diagram, this is the length L. Right, that means PM is SA divided by L. You need to remember this formula. PM, that is the indicated mean effective pressure, is SA divided by L. S is the spring value of the spring used, A is the area of the indicator diagram, and L is the length of the indicator diagram. This area and length don't get confused with the actual area of the cylinder length of the piston. Right, length of stroke or length of piston, length of piston and area of the piston or area of the cylinder there. Don't get confused with that. That is different, this is different. PM, mean effective pressure, we have the area of the indicator diagram, this area, and length of the indicator diagram L there. And stroke length is different. Stroke length we will be representing it by capital L, and area of the piston or area of the cylinder will be representing it by capital A. Small letter A is the area of the indicator diagram. Small letter L is the length of the indicator diagram. That is used only in the mean effective pressure formula there. Okay. Next one is the indicated power. Indicated power is nothing but the total power which is developed inside the engine cylinder. We call that power as the indicated power there. To find out that, we have the formula. IP is the indicated power, N PM, PM is indicated mean effective pressure, LANK divided by 60 into 1000 into 10 raised to 5 here. Right. Now, what is N? N is the number of cylinders. Right, like in four wheelers we might be having 4 cylinders. That means N becomes 4. In two wheelers we will be having single cylinder. That means N becomes 1. in some of the engines like trucks and all, we might be having 6 cylinders, 8 cylinders. Then n becomes 6 there if the truck is having 6 cylinders. If that engine is having 8 cylinders, then it n becomes 8 there, right? PM is the indicated mean effective pressure. It can obtain directly with the help of this formula, or else in the numerical he might be giving the mean effective pressure there, right? And L is the length of stroke, right? L is the length of stroke, and A is the cross sectional area of the piston there. Like if I write the piston and cylinder arrangement here, is the piston here and cylinder arrangement. Let us assume the maximum distance traveled by the piston here is the this area, that is TDC. It is the maximum distance which a piston can move up to the cover end or the top dead center, and let us assume this is the minimum area or the last point where it can reach the piston can reach the bottom dead center. Let us say it is BTC. The distance traveled by the piston is called as the stroke, that is capital letter L, and this cross sectional area is called A, that is capital A here. This cross sectional area is capital A, right? Then what we have? We have N. N is the speed of an engine or the speed of crankshaft. Here we have the crankshaft. This speed RPM. This is in RPM. This is nothing but the N, that is speed. K is half for 4-stroke engine and 1 for 2-stroke engine. To have the generalized formula, we have this one, because the power is produced in every 2 rotation for 4-stroke engine. That means the power is produced for every 2 rotation for 4-stroke engine. That's why K is equals to half. That means N divided by 2 is the IP. IP, to find out for 4-stroke engine, we have N divided by 2. Instead of writing that two different formula, we have one generalized formula, that is NPM LANK. K is half for 4-stroke engine, K is equals to 1 for 2-stroke engine. Why? Because for every one rotation, once the power stroke is produced in 2-stroke engine, that's why K is equals to 1 for 2-stroke engine and K is equals to half, because for every 2 rotation of the crankshaft we have 1 power stroke. That's why K is equals to half for 4-stroke engine, right? Now to have that K value, I have done the derivation for both the cases. You can go through this, right? Derivation for IP I have done. This is not there in your syllabus, though I have written in the notes. You can go through this thing, right? Now next one we have is the BP, that is brake power, right? Brake power means whatever the power which is produced inside the engine cylinder is the IP. This is the IP here. That means what is the power which is available at the crankshaft, we call that one as BP. That means due to the movement of the piston, connecting rod, crank and the crankshaft, due to this movement, right, there will be some losses, right? That losses is called as FP. That means that is IP minus BP is frictional power, right? Now what is brake power? This is the net power available at the crankshaft. We call that power as a brake power, right? BP is given by 2 pi nt divided by 60 into 1000, right? Here N is in RPM, T is the torque, right? But in belt drive we use T as tensions, right? That is not torque there. T is the tensions there, right? Here in IC engine, T is the torque. It is given by Newton meter, right? In Newton meter, it is force into distance is the torque here, right? Force into perpendicular distance is the torque, that is Newton meter is the unit here, right? And 2 pi nt divided by 60 into 1000 is the brake power. That is brake power. That means the power which is available at the crankshaft, we call that power as brake power, right? To find out that, we have two different means to measure the brake power. In that, first one is the belt dynamometer, right? Belt dynamometer, that means the belt dynamometer is like this. We have the two pulleys, driver shaft and the driven shaft, and in between that the belt is connected here. Here what we have, here the crankshaft is connected to the driver shaft, right? One is the driver shaft, two is the driven shaft, right? Now what happens, due to this movement, there will be a tension T1 in tight side, tension T2 in the slack side there, right? So the torque is given by force into perpendicular distance. Force is difference between these two here, right? That is tension in tight side minus tension in slack side, right, into R, right? R is the perpendicular distance here, right? That means this distance is the belt dynamometer, right? T1 minus T2 into R. That is, T1 is the tension in tight side of the belt, T2 is the tension in slack side of the belt, and R is the radius of pulley. Next we have is the rope brake dynamometer, right? Rope brake dynamometer is like this. We will be having the one which is connected to the end, and we have the pulley here. Pull around the pulley, the rope will be wounded here, and we have the W. Here we will be having the spring S. Right. Now what we have, it means the rope will be starting like this and wounds the pulley and come down like this, right? And this is the W and this is the S here, right? Now to find out that, and here it is connected to the crankshaft. Here directly it is connected to the crankshaft here, right? Now rope brake dynamometer, again torque is force into distance. Force is the effective brake load. Effective brake load is the W is the weight suspended and S is the spring balance reading, that is in newtons, into drum radius, that is R, right? Now R is the radius of drum. Here in radius of drum, we can, if the rope diameter is also given, right, radius of drum is the capital D divided by 2 if the diameter of rope is not given. If the diameter of rope is given, that is capital D plus small d divided by 2. Capital D is the diameter of the pulley and small d is the diameter of rope. This is what the R is, right? If they have given the diameters of the rope also there, right? Now as I told, due to this movement, that is the movement between the friction between the piston, friction in the moving parts of the connecting rod, right, and the friction between the moving parts in the crankshaft also, crank also, there will be some losses due to this friction, right, due to the mechanical parts which are moving in between those, right? That losses is represented by Fp, that is the frictional power. It is nothing but Ip minus Bp, Ip minus Bp. Ip here is the indicated power, that is power which is developed inside the engine cylinder, and Bp is the power which is produced at the crankshaft, right? That is what the frictional power is, right? Now the frictional power is the amount of power lost due to friction of the moving parts inside the engine cylinder. We call that power as frictional power, that is Ip minus Bp is given in terms of kilowatt. And next one is the mechanical efficiency. Mechanical efficiency is the ratio of brake power divided by indicated power. It is a ratio of Bp divided by Ip into 100. That is what the mechanical efficiency is, right? Now thermal efficiency. Thermal efficiency, we have two different types. Now what is thermal efficiency? Thermal efficiency is the ratio of power output to the heat supplied by combustion of fuel. That is the ratio of power output to the heat supplied by combustion of fuel, right? That is power output. Power output, if we are taking the indicated power, that is indicated thermal efficiency, then indicated power divided by heat supplied. Right. Now, power output, heat supplied is given in terms of mass of fuel into calorific value. Mass of fuel into calorific value. Mass of fuel is taken in terms of kg per second. Next, CV is kilojoules per kg. At the end, we'll get in terms of kilojoules per second. Kg get cancels. Remaining will be kilojoules per second. Right. That first we told it is for the indicated thermal efficiency. For indicated thermal efficiency, we have the formula, that is the ratio of indicated power to the heat supplied by combustion of fuel. Ratio of heat supplied to the the ratio of indicated power to the heat supplied by combustion of fuel. That is indicated thermal efficiency is IP divided by MF into CV. Next we have brake thermal efficiency. Brake thermal efficiency is the ratio of brake power to the heat supplied by combustion of fuel, that is BP divided by MF into CV. That is what brake thermal efficiency is. Next one is brake specific fuel consumption, BSFC. That is the mass of fuel consumed per 1 hour by an engine in developing 1 kilowatt brake power here. This is mass of fuel consumed in kg per hour divided by brake power developed in kilowatt here, right? This is what the mass here. See, don't get confused. MF is the mass of fuel consumed. MF here is in terms of kg per second. Here mass of fuel is in terms of kg per hour, right? Don't get confused with that. Always remember, mass of fuel consumed in BSFC is in terms of kg per hour, but here in thermal efficiencies, mass of fuel consumed is in terms of kg per second, or else you can convert this into mass of fuel consumed for kg per second also, like divided by 3600, 60 into 60, right? Next, we are going to solve some numericals on this. First, I have taken this numerical. A 4-stroke spark ignition engine develops maximum brake torque of 180 Newton meter here, right? That means what he has given? He has given a 4-cylinder 4-stroke SI engine, right? Always remember, when he has given the number of cylinders and which type of stroke, you need to write first n. Small letter n is equals to 4, because he has given 4 cylinders. Now 4 stroke means K, you need to write here, K is equals to half, because it is 4-stroke SI engine, and you need to represent which type of engine. Spark ignition, that is a petrol engine here, right? Then what is given? It develops a maximum brake torque of 180 Newton meter here. That means he has given torque T is equals to 180 Newton meter. Then at he has given speed, capital letter N is equals to 3200 rpm. Right. Then what is given? Calculate the engine displacement. Engine displacement is nothing but the stroke. Find out L, and bore diameter, that is capital D. Right. Engine displacement, bore diameter. Sorry, engine displacement is the volume, stroke volume. This engine displacement is a stroke volume, and he has asked bore diameter and stroke length, that is capital L. Right. Engine displacement is the engine volume, what he has asked, right? Then he has asked the brake mean effective pressure at maximum torque point is, he has given brake mean effective pressure. PM is 1150 kilopascals. Right. Then what he has given? Assume bore diameter is equals to stroke length. That means D is equals to L. Right. This is what he has given. Right. Now, to find out that, what are the equations we have? First equation we have here is the PM. Right. In PM, do we have the bore diameter and stroke length? Right. We have only SA divided by L. S is the spring value of spring used. A is the area of the area of the indicator diagram. L is the length of indicator diagram here. Next we have IP. In IP formula, what we have? NPM LANK divided by 60 into 1000. That means L is the length of stroke, A is the area of the cross sectional area of the piston or cross sectional area of the cylinder there. Right. So in this we have the diameter and length. We need to use this formula here. Right. Now we have indicated power IP is equals to N PM L A N K divided by 60 into 1000 into 10 raised to 5. Right. Now we have N, we have PM. PM is there. L is what we need to find out. A, in A and L we can find out with the help of this, and K we have the K is half here. Right. Now we can substitute directly in this formula. Right. Now here PM is given as 1150 kilopascals there. Right. PM is given as 005 into 10 raised to 3 pascals. Right. Now because we have taken this in terms of bar, right, this we have taken in terms of bar, we have 1 bar is equals to 10 raised to 5 Newton per meter square. Right, we have 1 bar is equals to 10 raised to 5 Newton per meter square, but this is in terms of pascals. Right, pascals is nothing but Newton meter, that is 1150 into 10 raised to 5 Newton per meter square. 1 pascal is 1 Newton per meter square, that we need to convert in terms of bar. Right. Sorry, this is 10 raised to 3. 10 raised to 3 here. So this becomes 1 Newton per meter square is equals to 10 raised to minus 5 bar. Right. So I can write this as 11.50 into 10 raised to 5 Newton per meter square, that is equals to 11.50 bar. Right. I can substitute 11.50 bar, or else I can directly use this and replace it by 10 raised to 5 there. Okay, I can omit 10 raised to 5 and I can write that formula, or else I can use this one and find out that thing there. Right. Now after that, what he has given? He has given D is equals to L. Right. Then I'll substitute the values. IP is equals to N is 4 into PM. I have got 11.50. L is what I need to find out, into L into area is pi d square by 4 into N. N is number of this one, RPM 3200 into K. K is half, whole divided by 60 into 1000 into 10 raised to 5. Right. Now, has he given IP? Yeah, he has not given IP also here. So we have two unknowns, that is IP is not there and L and D is not there. So I'll write IP is equals to 4 into 11.50 into now in L is equals to D, so I'll replace L by D there, D into pi into D square divided by 4 into 3200 into half into 10 raised to 5 whole divided by 60 into 1000. Right. Now there are two unknowns, that is D is unknown and IP is also unknown. Right. Now we cannot solve with the help of this. Right. Now to find out IP, he has not mentioned anything about the BP there. Right. He has not mentioned anything about the BP. He has not mentioned anything about the frictional power also. Right. So I can assume, now we will be assume BP is equals to IP. Right. Why I am assuming? Because he has not given anything about IP there and he has not given anything about BP there. That means and he has not given anything about the frictional power also there. Right. So I can assume there is a this operation is with respect to frictionless movement. This operation is with respect to frictionless movement. So BP, the formula of BP is equals to 2 pi n t divided by 60 into 1000. Right, 2 pi n t divided by 60 into 1000, that is 2 into pi into n here is 3200 into 180 divided by 60 into 1000. Right, because he has given torque as 180 Newton meter, so I have taken this one. Now calculate BP, will get the value as 60.31 kilowatt. Now substitute that in place of IP, that is 60.31 kilowatt here. Now only unknown here will be the diameter D. Find out diameter D. Now diameter D is equals to 85.55 mm. That is equals to length L. Always remember, whatever the values you get, please highlight that in box here. Right. Now after that, what he has asked? He has asked to find out the stroke volume, that is engine displacement. Right. Engine displacement, Vs is the stroke volume. Right. Vs is the stroke volume. I'll be writing that as engine displacement as pi by 4 into d square into L, that is the volume of that single engine, into N. N is number of cylinders there. Now a number of cylinders is 4 here into pi by 4 into here 85.55 into 10 raised to minus 3, because always remember, whatever you get, write that in terms of meters here also, into 10 raised to minus 3 meter. Right, into 85.55 into 10 raised to minus 3. So Vs is the engine displacement, will get in terms of 0.001967 meter cube. This is the engine displacement here. Right. Now we'll solve the next numerical. Now in this numerical he has given an IC engine working on 4-stroke cycle has a bore diameter of 110 mm. Right. Now he has given it is a 4-stroke cycle. 4-stroke cycle, that means K is equals to half. It is not told whether it is an petrol engine or diesel engine here. Right. In the first sentence, an IC engine working on 4-stroke cycle as a bore diameter of 110 mm and stroke length. Bore diameter capital D is equals to 110 mm, that is 0.11 meter, and stroke length L is equals to 120 mm, that is 0.12 meter, running at 480 rpm, that is capital letter N is equals to 480 rpm. Then what is given? The indicator diagram area is 4 centimeter square, that is small letter A. Right. Here it is the indicator diagram area, not the area of the cylinder or area of the piston. So I am writing in terms of small letter A, that is centimeter square. Right. That is when I convert centimeter to meter is 10 raised to minus 2, centimeter square to meter square it is 10 raised to minus 4 there. Right. Now it is 4 into 10 raised to minus 4 meter square, that is the area of indicator diagram, and length of the indicator diagram, that is small letter L, is 6.8 centimeter. Convert this also into meter. 6.8 into 10 raised to minus 3 meter. Now the spring value of spring used is 10 bar per centimeter into meter square. Right. Now the spring value of the spring used here is the S. S is equals to 10 bar per centimeter. Right. Now spring value of the spring is 10 bar per centimeter per meter square. Per meter square what we have. Right. Now what is asked? Find the indicated power of an engine. Right. Find the indicated power. IP is what he has asked to find out. Right. Now to find out IP, right, to find out IP we have the formula IP is equals to N PM L A N K divided by 60 into 1000 into 10 raised to 5. Right. Here we know N, we don't know PM, we know L, we know area A, and N is known, K is known, and everything is known, but PM is what we need to find out. Right. To find out PM we have formula SA divided by L. Right. Now SA divided by L. Now S is the spring value of spring used, and A is the area of the indicator diagram, and area of indicator diagram, and then L is the length of indicator diagram here. Right. Now spring value of spring used, it is in terms of bar per centimeter per meter square. Okay. Now if I write that one directly, that is 10 bar per centimeter per meter square into area of indicator diagram, that is 4 into 10 raised to minus 4. Right. bar per centimeter per meter. So better what I'll do, I'll write everything in terms of centimeter itself here. That is 10 into 4 area divided by 6.8, because here whatever I get yes is in terms of bar per centimeter into centimeter square divided by centimeter here. So I'll get in terms of centimeter, centimeter square, centimeter, centimeter get cancels, remaining will be bar. And because the PM I'll be utilizing that in terms of bar itself there, right? So what I'll get, that will be 10 into 4 divided by 6.8 is 5.88 here. PM will be 5.88, that is bar, right? Now substitute that in IP formula. IP is equals to N is he has given an engine working on 4-stroke cycle has a bore. He has not mentioned anything about number of cylinders, right? So number of cylinders, assume it as 1, into PM is 5.88 into L is 0.12 into area he has given diameter there, that is pi into 0.11 pi d square divided by 4 into n is 480 into k is half into 10 raised to 5 whole divided by 60 into 1000. Right, now find out this. IP will be 2.68 kilowatts. Right, now here what he has given here is this. Whenever you substitute, either substitute everything in centimeter or convert everything in meters here, right? When you convert this in terms of meter here, spring value of the spring used is bar per centimeter, that's it, right? Bar per meter or bar per centimeter here. This question, it is bar per centimeter, that's it here. So what you will get here is if I substitute that PM in terms of bar per meter, I'll get PM. S is bar per centimeter, that is 10 centimeter to meter. I need to multiply it by 10 raised to minus 2 here, into this one is 4 into 10 raised to minus 4 whole divided by, and area SA divided by L. L is 6.8 into 10 raised to minus 2. This is not minus 3, it is minus 2 here, because centimeter to meter, the 10 raised to minus 2. Again also we will get the same value, that is 5.88 itself, right? Minus 2 minus 2 minus 4 will get cancels off, you will get 5.88 bar itself, right? So either you can substitute everything in terms of meters or everything in terms of centimeter here, right? Now we got PM as 5.88 bar and IP as 2.68 kilowatt. We'll go to next numerical number 3, right? In this, what he has given is given a 4-stroke IC engine has 6 cylinders. A 4-stroke IC engine has 6 cylinders, that is N is equals to 6. 4-stroke IC engine, that is K. He has not mentioned anything about this one K here. A 4-stroke IC engine has 6 cylinders developed. He has not mentioned anything about K. Does not worry. Then what he has given? He has given the IP is 55 kilowatt. Right? IP is equals to 55 kilowatt at mean effective pressure. Mean effective pressure PM is 6 bar, and he has given bore and stroke of the engine is 80 mm and 100 mm. Bore is the diameter, D is equals to 80 mm, that is 0.08 meter, and length is 100 mm, that is 0.1 meter. Then if the engine speed N is equals to 3630 rpm, find the misfire. Right, we need to find out the misfire per minute. Right, to find out misfire per minute here. Right, now to find out this misfire, what we'll do here is we're going to find out the number of fires per second. Right, now here he has given here he has not given the value of k. Right, here he has not given the value of k here. Right, so I'll assume the value of k is 1. Right, that means let us take this as a two-stroke engine. We can assume anything, like you can assume value of k is equals to 2 also there, or else value of k is equals to 1 also there. Right, so better I'll take this as a two-stroke engine, a four-stroke engine itself. That is, I'll take this as value of k as half, because most of the case we have the four-stroke engine itself. Right, for four-stroke engine I can take value of k as half there. Right, now what I'll do, I'll utilize the formula given here, that is IP he has given, right, and I'll find out the actual number of this one revolution. That means IP is equals to npm LANK npm LANK divided by 60 into 1000 into 10 raised to 4, sorry 10 raised to 5 here. Right, now I'll substitute that completely. IP is given as 55 kilowatt. 55 is equals to n number of cylinders, that is 6, into PM is 6 bar, into length he has given 0.1 meter, into A pi into 0.08 square divided by 4, into K is half, right, into 10 raised to 5 divided by 60 into 1000. Right, and one more thing, that is n, capital letter N here. Right, in complete this the n here is the actual number of revolution, actual RPM here. N here is the actual RPM. This is the actual RPM which is running when the IP is 55 kilowatt here. Right, now find out the value of n. You will get n as, only unknown here is n, so you will get n as 3647 RPM. N here is 36447 RPM for 55 kilowatt IP. Right, 55 kilowatt IP here. That means when you compare this with the engine speed, Now the engine, this is actual, I'll write this one as actual. This is the theoretical one, right? Now the actual is n act, actual is 3630 rpm, right? Now the engine speed is this much, right? Actual thing. Now when I take the theoretical uh, explosions, when I take the theoretical explosions, or a number of explosions here, number of explosions means when the spark is ignited. Number of explosions means number of times the spark is ignited per minute, right? Now as it is, we have considered this as a 4-stroke engine, because n we have considered it as half here, right? N is half here, that means it is a 4-stroke engine. So number of explosions, that means for every 2 rotation of the crankshaft, once the explosion is happening, right? That means it is capital letter N divided by 2 here, right? So number of explosions becomes is equals to, that is 3647 divided by 2. Will you will get this as 1823. This is explosions per minute, right? But the actual one, the actual explosions, actual explosions is actual rpm divided by 2. This actual rpm we have 3630 divided by 2. Find out this, we'll get the actual rpm, actual explosions as 1815 actual per minute, right? So the misfire is equals to the number of explosions theoretical one minus actual explosions, right? So I have 1823 minus 1815, so I'll get this as 8 misfire per minute, right? This is what the misfire means. That means when the indicated power which is produced inside the engine cylinder, you need to find out that, and you need to find out the rpm, right? Due to the indicated power which is produced inside the engine cylinder, the rpm which is produced because of this indicated power which is produced inside the engine cylinder will be greater than the actual actual rpm of the engine cylinder. So due to that difference, we have some misfires, right? If it is a 4-stroke engine, so misfires or the explosions will be rpm divided by 2. If it is a 2-stroke engine, explosions will be rpm itself, rpm divided by 1 here, right? So you can subtract that, the actual explosions, number of explosions, that is theoretical one, and the actual explosions, that difference will give you the misfire, right? Thank you.